Like other graphs in this course, we don't really want to have the situation where we just want to plot points. That's not the idea, is to plot points and see what happens. What we want to do is make sure we understand exactly what's the nature of the curve. So you've got to know exactly what sine of x, cos of x will look like, and what tan of x will look like. What will those curves, what will be the general shape of those curves? And then also the other important parts is where is it going to go through the x and y axes? Because you can solve, you can put x is equal to 0 and y is equal to 0 to work out that. But also we should know the period of the functions as well as the amplitude. Now the amplitude, if we got our function in terms of a sine n times x, so if we get our functions will be something in that form. A will be our amplitude. So that will tell you how far it's going to be above. So for the simple fact that sine of nx, the greatest value of that you can ever get is 1. So whatever multiplies out the front, that the highest number we get would be that number times 1. Everything else is going to be a fraction. So that's why a would be its amplitude the further it goes away. The period would be determined by 2 pi on n, and we generally use the symbol t to denote period. So 2 pi on n, and where n is the number in front of x, will tell you the period, so what size is the cycle before it starts again. So if we investigate that on this graph over here, sine of x is going to be our pink curve here. So pink curve is, sorry, the blue curve is sine of x. So the effect that multiplying it by 2 out the front really only has the effect of doubling every y value. So the orange curve, you notice every y value is doubled from the blue curve. So if we see that where it's 0, it will remain 0. Where it was pi on 2, sine of x was 1. So 2 sine of x will be equal to 2. Every value is doubled, whether it's positive or negative. So that's the effect. Just has the effect of increasing the amplitude, but doubling every value that we've got and pushing in that direction. The sine 2x though, this is the case where now if we put our period, we'd see that that'd be 2 pi on n, and n is 2, so 2 pi on 2 means we've got a period of pi. It actually starts to shorten the curve up. So the pink one is what sine of 2x. Notice that it only takes one rotation through the pi to get, the pi units to get through that one rotation. So we can see that every value here has been squashed. So the curve's basically been squashed between 0 and pi now. All the values here, where it was pi on 2, now pi on 4 will be equal to 1, because 2 times pi on 4 will equal 1. And we get that so on, all the other values as well. So within 2 pi, it does 2 revolutions now, if it's sine of 2 pi. The larger that number, the smaller the period. The smaller this number, the larger the period would be. If that was sine of a half x, our period would now become 4 pi. So there's the effect of putting a number in front, what it does to the curve, and a number in front of the angle width, and a number here in front of the angle x.